In the most dangerous years of the 20th century, when the world lived under the constant threat of nuclear war, the United States quietly built a machine so advanced that even its greatest rival could barely comprehend it. Deep in the Nevada desert, far from the eyes of the public and hidden behind layers of secrecy, American engineers were designing an aircraft that would become one of the most extraordinary technological achievements in aviation history. When this aircraft finally began flying missions near Soviet territory, radar operators across the Soviet Union started seeing something that made no sense. A target appeared on their screens moving faster than anything they had ever tracked before. Fighter jets couldn't catch it, surface-to-air missiles struggled to reach it, and before Soviet commanders could even react, the mysterious aircraft had already vanished from their airspace. That aircraft was the legendary Lockheed SR-71 Blackbird, and during the height of the Cold War, it became one of the most powerful symbols of American technological superiority. To understand why the Blackbird mattered so much, you have to understand the world in which it was created. The Cold War was not just a military conflict between the United States and the Soviet Union. It was a global competition for power, influence, and survival. Both superpowers possessed thousands of nuclear weapons capable of destroying civilization, and both sides were desperate to understand what the other was building. Intelligence gathering became one of the most critical aspects of the conflict. If one side secretly developed a new missile, bomber, or nuclear system, it could potentially shift the balance of power overnight. For American leaders in Washington, the biggest challenge was simple but terrifying. The Soviet Union was a closed society. Almost nothing that happened inside its borders was visible to the outside world. This meant that American intelligence agencies needed a way to look inside Soviet territory without starting a war. In the early years of the Cold War, the solution was high-altitude reconnaissance aircraft like the Lockheed U-2. These aircraft could fly higher than most Soviet fighters and were designed to photograph military bases, missile sites, and nuclear facilities. For a few years, the U-2 seemed almost untouchable. It could fly above 60,000 feet, far beyond the reach of most air defenses at the time. American planners believed they had found the perfect solution to the intelligence problem. But that illusion didn't last forever. On May 1, 1960, a U-2 flown by American pilot Francis Gary Powers was shot down deep inside Soviet territory by a surface-to-air missile. The aircraft crashed, the pilot was captured, and the incident caused a massive international scandal. Suddenly, the United States realized something alarming. The Soviet Union's air defenses were improving rapidly. High altitude alone would no longer guarantee safety. If the U-2 could be shot down, then any future reconnaissance aircraft would need something far more powerful than altitude as its defense. The answer was speed. Incredible, almost unimaginable speed. Inside the secretive Skunk Works division of the aerospace company Lockheed Corporation, a team of engineers led by the legendary designer Clarence Kelly Johnson began working on a radical concept. Instead of trying to fly higher than enemy missiles, the new aircraft would simply outrun them. It would travel so fast that by the time enemy defenses could react, the aircraft would already be gone. To accomplish this, the team needed to design a plane capable of flying at more than 3 times the speed of sound, while surviving temperatures that would melt conventional aircraft. The engineering challenges were enormous. At speeds above Mach 3, the friction between the aircraft and the air would heat the surface of the plane to temperatures exceeding 300 degrees Celsius. Aluminum, the material used in most aircraft, would simply soften and fail under such conditions. The engineers needed something stronger and more heat-resistant. Their solution was titanium. Nearly 90% of the aircraft structure would be built from this incredibly strong metal. Titanium allowed the aircraft to survive the intense heat created by sustained supersonic flight. Ironically, however, there was a problem. At the time, the United States did not produce enough titanium domestically to build the aircraft. The solution required an elaborate intelligence operation. Through a network of shell companies and international intermediaries, the United States secretly purchased titanium on the global market. Much of it ultimately came from the Soviet Union itself. Without realizing it, the Soviet government was selling the raw materials that would later be used to build one of the most advanced spy planes ever created to observe their own military installations. When the aircraft was finally completed, it looked unlike anything that had ever flown before. Long, sleek, and painted entirely black, the aircraft's design was optimized for extreme speed and reduced radar visibility. The black paint helped dissipate heat generated during high-speed flight, while also absorbing radar energy, making the aircraft harder to detect. The shape of the fuselage, the angled vertical stabilizers, and the distinctive engine nacelles were all carefully designed to manage shock waves and airflow at hypersonic speeds. The engines themselves were a technological marvel. The Blackbird used massive turbojet engines known as the Pratt & Whitney J58, but these engines behaved differently from conventional jet engines. At extremely high speeds, they transitioned into a hybrid mode that functioned partially like a ramjet engine, using the tremendous pressure of incoming air to generate additional thrust. This allowed the aircraft to cruise comfortably at speeds above Mach 3 while maintaining enough efficiency to travel thousands of kilometers during a mission. Flying the SR-71 was unlike any other aircraft. The cockpit environment was so extreme that pilots had to wear full pressure suits similar to those worn by astronauts. At 80,000 feet, the sky above them appeared almost black, and the curvature of the Earth was clearly visible through the canopy. Inside the aircraft, two crew members worked together. The pilot controlled the aircraft itself, while the reconnaissance systems officer operated the sophisticated cameras and sensors used to gather intelligence. But the true genius of the aircraft was its defensive strategy. The SR-71 carried no weapons. There were no missiles, no guns, and no bombs. Its only defense was its speed. During reconnaissance missions near hostile territory, Soviet radar systems frequently detected the aircraft. Missile batteries would lock onto the target and launch surface-to-air missiles in an attempt to intercept it. These missiles could travel extremely fast, sometimes approaching similar speeds to the Blackbird itself. But speed alone wasn't enough to guarantee a successful interception. A missile must predict where the aircraft will be in the future in order to intercept it. At Mach 3, that prediction became incredibly difficult. Pilots flying the SR-71 were given a surprisingly simple instruction when they detected a missile launch. Instead of performing complex evasive maneuvers, they were told to simply accelerate. As the aircraft pushed beyond Mach 3, the missile chasing it would gradually fall behind. The faster the Blackbird flew, the harder it became for the missile to catch up. Over the decades that the aircraft was in service, Soviet radar systems reportedly launched hundreds, possibly thousands of missiles at the SR-71. Not a single one succeeded in shooting it down. For Soviet commanders, this was both frustrating and alarming. Their radar systems could detect the aircraft, their missiles could attempt interception, but nothing seemed capable of stopping it. The Blackbird had effectively turned speed into an impenetrable shield. In many ways, it represented a new kind of strategic advantage in the Cold War. Technological dominance so overwhelming that the opponent could only watch it happen. Despite its incredible performance, the SR-71 did not remain in service forever. By the late 1980s and early 1990s, new technologies were beginning to replace manned reconnaissance flights. Advanced spy satellites could photograph targets from orbit without risking pilots, and unmanned drones were becoming increasingly capable. At the same time, the SR-71 was extremely expensive to operate. Each hour of flight required enormous logistical support and cost tens of thousands of dollars. Eventually, the U.S. Air Force decided to retire the aircraft in the late 1990s. By that point, however, the Blackbird had already secured its place in history. Even decades after its retirement, it still holds records as one of the fastest and highest-flying operational aircraft ever built. Today, the SR-71 Blackbird stands as one of the greatest achievements of American engineering during the Cold War. It was a machine born out of secrecy, innovation, and intense global competition. At a time when the balance of power depended on knowledge, the United States created an aircraft that could gather intelligence from almost anywhere on Earth, while remaining nearly impossible to stop. And for years, as Soviet radar screens tracked a black shape racing across the upper atmosphere faster than any missile could catch, the message was unmistakable. In the technological race of the Cold War, American innovation had reached a level that even its greatest rivals struggled to match.